we float on a speck of dust in a vast cosmic ocean. This is our home Earth, a world of impossible complexity, born from stardust and governed by invisible laws. The most familiar of these is gravity, the silent conductor of the cosmic ballet. It holds our feet to the ground, binds our moon in orbit, and gathers gas and dust into the stellar furnaces we call stars. Our Sun, a rather average star, is one of hundreds of billions in the Milky Way galaxy. Each point of light in our night sky is a distant sun, many with their own families of planets. For millennia, we looked up and wondered. Now, we know. We've sent probes to our neighbors, mapping the canyons of Mars, peering through the acid clouds of Venus, and marveling at the colossal storms of Jupiter. We've discovered thousands of exoplanets orbiting other stars, confirming that our solar system is not unique. This is the universe we can see, the one we can measure. It is a place of breathtaking scale and clockwork precision. From the spin of a galaxy to the orbit of an electron. But this tangible reality is only a sliver of the whole story. Beyond the familiar glow of stars and galaxies lies a profound darkness, an unseen universe that dwarfs our own. Here, gravity behaves in ways that defy our expectations, hinting at the presence of something more. We call it dark matter. It does not emit or reflect light. Yet its gravitational influence is the invisible scaffolding upon which galaxies are built. It outweighs all the visible matter in the universe, 5-1. Yet we do not know what it is. It is a ghost in the cosmic machine. And then there is the even greater mystery, dark energy. We once believed the expansion of the universe, initiated by the Big Bang, was slowing down, but it is not. It is accelerating. Some unknown force is pushing everything apart, a cosmic anti-gravity that will ultimately determine the fate of the universe. This dark energy makes up the vast majority of the cosmos, a silent, pervasive energy of the void itself, at the edges of our understanding. We also find black holes regions, where gravity is so intense that nothing, not even light, can escape. They are singularities, points of infinite density, where the laws of physics, as we know them, break down. They are portals to the unknown, challenging the very fabric of space-time. As we peer deeper into the unseen, the line between physics and philosophy begins to blur. The bizarre rules of quantum mechanics, which govern the subatomic world, suggest that reality itself is not as solid as it appears. Particles exist in a haze of probabilities until observed. The act of measurement seems to conjure reality into being. Does this imply that consciousness is not just a passenger in the universe, but a participant in its creation? This leads to even more profound questions. If our universe is governed by a precise set of physical laws, are other universes possible, each with its own unique laws? This is the concept of the multiverse, an infinite tapestry of parallel realities. And if infinite universes exist, does that mean every possible outcome, every choice you've ever made or could make, is playing out in some other reality? Taking this a step further, some physicists and philosophers speculate about the simulation hypothesis. Could our entire universe, with all its intricate laws and emergent complexity, be a sophisticated computer simulation created by a more advanced intelligence? How could we ever prove or disprove it? The ultimate nature of reality may be forever beyond our grasp. We are explorers on the shore of a cosmic ocean, and with every new discovery, the ocean only seems to get larger. The journey into the unknown is the greatest adventure of all. Ever wonder where it all began? Let's rewind the clock. Way back, about 13.8 billion years ago, our entire universe was smaller than an atom. In an instant, this wasn't a bang in the traditional sense, but a rapid, unimaginable expansion of space itself. This is the Big Bang. In the first fraction of a second, a process called cosmic inflation ballooned the universe at a speed faster than light, smoothing out the cosmic fabric. As it cooled, fundamental particles like quarks and electrons emerged from the primordial soup of energy. For about 380,000 years, the universe was a dense, hot plasma, too chaotic for light to travel freely. Then, it cooled enough for the first atoms to form, mostly hydrogen and helium. The universe became transparent, and the first light, the cosmic microwave background, was free to journey across space. A faint echo of creation we can still detect today. This was the dawn of the cosmos, the beginning of everything we know. So, with billions of galaxies, each with billions of stars, where is everybody? This is the heart of the Fermi paradox. The math suggests the universe should be teeming with life, maybe even advanced civilizations. Yet, we've found nothing. Complete and utter silence. Is it that life is incredibly rare? Or maybe intelligent life inevitably destroys itself? Perhaps they're hiding, observing us from a distance. Or could it be that we're just not looking in the right way? This is where SETI, the search for extraterrestrial intelligence, comes in. For decades, scientists have been scanning the stars, listening for a signal, a whisper from another civilization. We've sent our own messages out into the void, like the Voyager Golden Record, a cosmic greeting card from humanity. So far, the great silence persists. But the search continues, driven by one of the most profound questions we can ask. Are we alone? The answer, whatever it is, will be staggering. Now, let's talk about something we all experience but can't quite grasp. Time. Why does it only flow in one direction? We remember the past, but not the future. This is the arrow of time, and physics points to a concept called entropy. Entropy is basically a measure of disorder. The second law of thermodynamics states that in an isolated system, entropy, or disorder, always increases. Think of an egg. It's easy to break it, increasing its disorder, but you can't unbreak it. The universe as a whole is moving from a state of low entropy, the highly ordered Big Bang, to a state of higher entropy. The arrow of time is simply the universe moving towards greater disorder. But what about eternity? Does time have a beginning and an end? Or is it cyclical, with universes endlessly born from the ashes of the last? These questions push the boundaries of physics and dip into philosophy. Time might be the most fundamental illusion or the most profound reality. As we journey through our own brief moments, we are part of this grand cosmic unfolding, riding the relentless, mysterious arrow of time. Thanks for watching, and don't forget to subscribe for more journeys into the cosmos.